Good morning friends. We will today see what the vectors are there. First line I want to say that vector is consisting of magnitude and direction. So first derivation we will make here that if out of a vector we remove its magnitude, what we are left with, that is the mere direction. So we can easily find the direction vector which is also known as unit vector is actually a vector and we have removed its magnitude. So vector divided by magnitude of vector. You just write this symbol goes for magnitude. You can just write magnitude of vector. So you can easily find a vector. Suppose I am telling you I have to find a vector whose magnitude is 5 and whose direction is along some unit vector, vector A. So what will be that vector? If its magnitude is 5, then it is 5, and direction, if I said it is along vector A, direction of vector A, and A is a unit vector here, then we can write a vector like this. So firstly be concerned how to find the direction vector. Very important, vector divided by its magnitude. Then we will develop how to find the magnitude. See, now what the unit vectors are there? We have just seen a vector whose magnitude is just 1 and it got only direction. Now we will see unit vector along x-axis is taken as I cap, unit vector along y-axis is taken as j cap, and along z-axis is taken as k cap. Suppose I have to represent a vector which got component of 2, 3 and 4 units along x, y and z axis. How we will write that vector? That vector will be 2 along with this direction plus 3 j cap plus 4 k cap. So we can easily find a vector if its corresponding direction vectors along different axes are given and we know the magnitude, what units it got along different axes. So you can find easily that vector. Now we will see how to find the magnitude of a vector, because for finding the direction vector of a given vector we need the magnitude. So to find the magnitude of this vector, if I have to find this will be, this symbol goes for magnitude of a vector. It is actually 2 square, that is the coefficient of vector along x-axis, that is coefficient of I cap, coefficient of j cap and coefficient of k cap, like this. So we will get the unit vector along vector A. This is magnitude, and unit vector we can easily get along vector A is actually the vector divided by the magnitude of vector. So it is coming out to be 2i plus 3j plus 4k divided by its magnitude, that is under root 4 plus 9 plus 16, that is coming out to be root under 29. So this is a unit vector along vector A. Now suppose I have to find a vector which got a magnitude of 10 and which is in the direction of vector A. So that vector will be, see here, if I have to find a vector B whose magnitude is something, suppose I am taking 10. So magnitude is 10 and it is in the direction of vector A. So we will pick up the unit vector along vector A that we have found out here. So we will just write 10 into 2i plus 3j plus 4k divided by under root 29. So this is a vector whose magnitude is 10 and which is along another vector, vector A. So we have picked up the direction of vector A. Now we will find resultant vector of two vectors. Very important law, the triangle law of vector addition. What does this say? That if a vector is along AB, another vector is along BC, then the resultant vector is vector AC. So what you can write? You can write vector AB plus vector BC is equal to vector AC. Okay, just very easy technique I am giving you here. Suppose I have to write vector AC in as a sum of two vectors. What I will do? I will start with the letter A and end with the letter C. How? If I am taking as vector AP, then I am leaving at P, so I have to start from P. Vector PC. First and last letter should be same. Suppose I want to write it like that AM, then I have to start from MC. Same way, suppose I have to write vector PQ as a sum of two vectors. Just very easy technique, no need of seeing the diagram all the time. If you just develop this technique, you can easily find the resultant of vectors. PQ can be written as PT plus, what is that? TQ. First and last letter is remaining same, and where the first vector is ending, the second vector is starting from that point only. So this is the resultant triangle law of vector addition. It is making your life very easy in finding the resultant of vectors. See, one question we are doing. ABCD is a regular hexagon. That means all the sides are equal. Express this in the terms of vector A and vector B. Suppose I have to find vector AC. What is given? Firstly, see what resources we got. And second thing, you just know what you have to find. See the resources with you and see what you have to find. The resources with you is vector AB is given, and that is vector A, and vector BC is given, that is vector B. That are the two resources. You have to make use of these two resources to find the other unknown things. Suppose I have to find vector AC. How can I write? Just following the triangle law, I can write it as vector AB starting with A, and the last letter is B for the first vector, so I have to start from B and last letter will be C. So vector AC can be represented as vector AB plus BC. Just make a habit of writing in that fashion. So vector AB, we know vector A, and vector BC is vector B. So vector EC we easily found out. No need of seeing the figure all the time and seeing where, in what direction the vectors are going. You can easily find out. See the next question, we have to find AD. Okay, just represent. How can you write? Vector AD you have to find. Okay. This is vector AD, and vector AD is, by geometry you can see that vector AD is double of vector BC. So it is easily 2 vector B. It is very easy, no need of using the triangle law here because that is obvious from the figure. It is given. So no need of using triangle law. Last question, vector AF we have to find. We will start AF, you just identify AF is here. So you have to take care of the triangle this only. So any fashion, no need of seeing the figure. You just write AF as AD plus DF. Very simple. Luckily you got AD. AD you can write as 2 vector B. Now concerned about DF. How to find the DF? Can you find DF easily? See from the figure some symmetry is there. Okay, so now you have to concentrate for DF. So DF can further be written in the terms of these triangles. DF as DE plus EF. Now see 2 vector B here. DE, what is DE? You see DE vector is equal to minus of vector A. because ED is equal to AB. So DE is equal to minus of AB. So you can write DE is equal to minus vector A plus EF. EF is equal to, you see, EF is equal to CB. So you can write EF is equal to minus of vector B. So this is minus of vector B. So what actually it is coming out to be? It is coming out to be vector B minus vector A. Very easily, we just follow the triangle law. We just found where AD we just got from the figure very easily. Now if we have to go for DF, we just broke out it into two subcomponents. That is DE plus EF according to the triangle law. Now we search for what is DE. DE is actually equal to BA, but we are given AB is vector A, so BA is minus of vector A, that we wrote here. And same way we got the value of EF is coming out to be minus vector B. So we got the result, and you just follow the triangle law, you can easily find the result. Hope you are understanding. Thank you. For useful videos, log on to my channel Santosh Pembi on YouTube, or directly go to my website www.mathsonphone.com. Thank you.